Good evening. All right, light waves. Let's talk about light waves. So how I see light waves isn't like electromagnetic radiation, where it's like a lot of things, a lot of confusion is the photon and the electron and stuff like that. And I say it's energy waves, and light is very different than electricity. Um, it's not a little packet. It's not a lightning bolt. It's a wave going through the electromagnetic field, like a shock wave. So heat expansion is what we see. All right. What do I mean by that? So heat is expansion, right? When something gets hot, it expands, right? And in the electromagnetic field, gravity, magnetism, it's all the same thing, right? It's a tensioning in a one way and a tension the other way, right? Counter tension. So what it is, you got expansion is basically spreading the field out, and then gravity is a return tension on that field, on that expansion. So light waves are basically when an atom basically releases that tension. Um, you look at the atoms and you get confused. It's easy to do so, which is why you got to scale from up to down, where you can see it, and then scale it down where you can see it. So how do you see it in a large scale? You look at the sun, it still gets kind of confusing because you're looking at the actual light with your eyes, and you're not seeing what's actually going on. Scale it up bigger. Yes, bigger. Two black holes collided. Before they even collide, they are sending out these shock waves throughout the electromagnetic field. We see them as a warping of space-time. We see them as a warp. We actually kind of like heat waves on the road. It warps things, but not quite, because it's actual waves, right? It's shock waves. So these two spiraling bodies are going in, and they're losing momentum, right? They're losing angular momentum and rotational momentum, and they're getting tighter and tighter and tighter and tighter and tighter and tighter and tighter, and tighter, and until it's a poof, right? And you get this massive expansion. And when we see that in two black holes or whatever the case, we call them gravitational waves. We can see it in our telescopes as basically the wave goes across in front of a light source, like a galaxy far, far away. We actually see it move. And we have measured these impacts from hundreds of thousands of light years away, millions of light years away. And we can literally use LIGO to detect the atomic structure shaking. They say it's the warp. They say it's the reality itself is stretching, and it's a vibration, man. It's straight up. It's the electromagnetic field, and on a atomic scale, that's how our eyeballs see light. It is a one atom basically shaking, and another atom farther away receiving that vibration. All right, it's not spooky. It's not. It's a little spooky, but it's not. It's angular momentum is what it is. So you have a unified field, and in that field is everything, right? And you have, when I say tension tightening and tension loosening. Tightening is gravity. Loosening is heat expansion. All right, but it's angular momentum is really what we're talking about. So as something spins, it's spinning everything around it. Okay, we can see it in galaxies, we see it in suns, we see it in planets, we see it in everything. Okay, so when it expands outwards, like a star exploding, when it expands outwards, all that energy goes, and then it starts going. All right, it's all angular momentum. It's all about conserving momentum, all right? And what we're seeing is heat, and all this other stuff is really just the field doing what it has to do, you know? And so universal expansion is literally just all that tension being released. Got it?